two.
Okay, so which ones, anything you want to look at?
I forgot how to do that, so I'm gonna just do number one.
So all of these, there, if you look at this thing, it's broken up into kind of parts. You got the first page and the second page are basically geometry problems. And then you got one that's like a consecutive number problem. But these are ones where you're going to set up some kind of a quadratic equation based on the situation. So like I'm not going to do the whole thing, but I would be willing to maybe like help you with number 4 a little bit, something like that. That might be a good one.
Sure.
Okay, so with number 4 then, and let me just take a picture of this. Make it a little bigger so everybody can read it.
Wait, all this whole package is due Wednesday?
Yes. Okay, so, all right, so I really want you to not be talking right now. I want you to be focused up here. I want you to be facing the front. Let's have a look. So how are we going to do this? What is the formula for the area of a trapezoid? Because that's what they're giving us here is the area of a trapezoid. Okay, so what is, let's back up even one step more. What is the definition of a trapezoid? Raise your hand. Somebody give me one thing that's true for trapezoid. Quadrilateral. What else? Okay, so it has one set of parallel sides. Okay, one pair of parallel sides. So it's a quadrilateral with exactly one pair of parallel sides, and I guess that's probably all we need, right? So then it would look like, if these are my parallel sides, it would look something like maybe, like that, for example. Okay? How do we label the sides of a trapezoid? Okay, so the bases are B1 and B2. And then what's the other part that we need to calculate the area? The height. Good, the height. And I want you to think about this. I'm going to tweak this just a little bit. I want you to think about this not in terms of memorizing a formula, right? I mean, how much do I hate memorizing formulas? A lot is the answer. Yes, I do. Because if you try to memorize a formula, you're just going to forget it, right? Guaranteed, you're just going to forget it if you try to memorize a formula. If we wanted to come up with an area of this thing, how could you reconfigure the area to be easier to calculate? Two triangles and okay, and we could even do something like what if I did this? What if I were to bisect both of these of the altitudes, or not the altitudes, both of the non-parallel sides, right there. If I bisect those, that would be the same thing as just running a line parallel to the bases that's halfway between the two and seeing where that intersects the other sides, correct? Everybody with me?
Yeah.
So if I bisect these things, now what if I did this? What if I cut off that little triangle so I made that a right angle? Okay, good, and I could just flip that up there and get something like that, couldn't I? Right? Couldn't I do the same thing over here? I could just cut this piece right here, so that's a right angle, and I'll just flip that up there, like so. Would you agree? And I end up with a rectangle. Okay, now what's the length? The height is just h, isn't it? Right? What's the length of the rectangle? Oh, it's going to be the average, isn't it? Right? Everybody see that? Because isn't the length of this segment right here, I got to pick a different color, the length of the purple segment, which is going to be the length of the rectangle, doesn't that have to be the average of the bases? Everybody see that? It's halfway in between, isn't it? Right? Okay, how could we prove that? Well, if I were to look at the entire length of the bottom base and the entire length of the top base, and I realize that when all is said and done, I'm going to have the same total amount of length that's invested in the two the two top and bottom sides of the rectangle, right? Everybody agree? I'm not gaining or losing any, I'm just gonna trim a piece off there and stick it up there, right? So then wouldn't it just have to be the average of the two, if I'm gonna split it equally? Right? So I end up with the length of this thing just being the average of the two bases, and that's how I can get it without ever having to remember anything. Right? I'm just reconfiguring that trapezoid, that's all I'm doing. Okay? All right, so now that I've got a formula, let's write that formula down. The area of a trapezoid is, how can I say that? Just that times that, right? But if it's h times b1 plus b2 over 2, I could even just pull that 1/2 out front and just do 1/2 times h times b1 plus b2 if I wanted, right? Okay? So what's it tell me here? Gives me height, doesn't it? Yeah, look at that. There's my height. It gives me the two bases, x plus 4 and x plus 9. So this isn't a big deal, then I can do this, right? If I'm just going to plug into my formula, here's my formula. So the area is 1/2 times h times b1 plus b2. Well, what's that look like? Plus.
X plus 9.
And I really don't need to put parentheses around those, I could. You can take it from there, can't you? Right? That make sense? Okay. I'm going to come up with an area, and then what's the area going to be equal to? 99. Yeah, so that whole thing, it's just going to equal 99. And now, when all the dust settles here, and so let's maybe look at one more little piece of this. I've got 1/2 times x minus 4. If I add like terms here, what do I get?
2x.
Okay, so what's the first thing you'd probably do here to make this a lot easier?
Like terms.
Why not multiply by 2? Right? Everybody see that? Because we don't want to deal with a fraction the whole time, distributing a fraction through. So if I were to multiply each side of the equation by 2, then when I multiply a bunch of factors, I must multiply in pairs anyway, right? So I'm going to multiply 2 times 1/2, get an answer, and then proceed to multiply that by the other stuff, right? So 2 times 1/2 would cancel, and over here I would just get a 198. Okay. And now if I FOIL this out, I'm just going to end up with a quadratic equation that I can put into standard form, right? 198. Yeah. Right, so on this side, well, I guess we can do a little bit more. So on this side, double 99 is 198. What am I going to get over here if I distribute? If I distribute the x, I'm going to get 2x squared plus 13x minus 8x gives me how many x's? There you go. And then finally, negative 4 times 13. There, right? Now I've got a quadratic equation. How could I put that into standard form? Yeah, just subtract 198, right? If I subtract 198, then I get what I want, which is a 0 on one side. And on the other side, on the left side, I'm going to get 2x squared plus 5x minus 250. Right? Okay, and really, I mean, we've already kind of switched into math mode, haven't we? The algebra mode. I mean, we did that clear up here where I really only needed geometry to get to here. And now I just switch into math mode and I'm just solving an equation, all right? So what could we do here? Probably quadratic formula, right? While we're doing quadratic formula, where would we want to start? With the discriminant. Okay, so what is my discriminant?
5 or 4 times 5.
Well, no, I'm getting b squared can be 25 minus, now we can do this one in our head, minus 4 times 2 times negative 250. We can do that in our head. That's not going to be a big deal. Minus 4 times 2 times negative 250. Well, positive, negative times negative is positive. What's 4 times 250? 1,000 times 2? 2,000. So I get 2,025.
Oh, that's like a couple years.
Okay. Is that a perfect square? What is that?
Is it actually 25?
No, it's not 25.
40.
45. There you go. Yeah. Okay, so if that's a perfect square, what's that tell us?
Not that.
I mean, we could quadratic formula this thing, and it's fine to do, because, I mean, it's pretty easy now that we know this is a perfect square. But what's our other option we could have here? Yeah, we could factor this too, couldn't we? Right? What do you prefer? To be honest, I just want to know. At this point, vote, raise your hand if you vote for quadratic formula. Anybody vote for factoring? Oh, okay, all right, no factoring. All right, that's fine. That's fine. So then quadratic formula, we're going to get x equals negative b plus or minus the square root of 2025, which is just 45, right? All over. Okay, so we got them, right? What are our two answers? If we take the plus, we get negative 5 plus 45.
Oh, well, all of it.
40 over 4 would be 10. There you go. So I get x equals 10. If I take the minus, negative 50 over 4, so negative 25 halves. Are those both good answers?
No,
Just one. Well, I think. Actually, we don't. Now, you're right, but just because x is negative, does that mean that doesn't work?
No.
No. What would I have to? What would I have to check to see that it really doesn't work?
You have to like put it in those equations to see if it's possible.
Okay, I'd have to see, and I got to look in the context of the original picture. So if the distances are, now look at the values we have up here. I've got an x minus 4 as the height. Well, there you know it's not going to work, is it? Because you can't have a negative height or a negative base length, right? So if I were to plug that value in, I'm going to get negative geometric lengths, and that's impossible, right? So this one, we can cancel, but the 10 is going to work. And we can check it pretty easily. Okay. So that's not what's being asked in the question. They want to know the length of the larger base. Okay, so the bases are x plus 4 and x plus 9, right?
So, B2.
So it'd be 10 plus 9 is 19, right? Yeah.
Why did everyone pause?
We're going to get 19, we're going to get 14, and we're going to get 6 for the height. So 19 would be the length of the larger base, longer base. Okay, make sense? Okay, so those are kind of tricky. I mean, you know, you gotta, there's a little bit to do in those. There aren't too many on this one though, are there? I don't think I gave you too many to do. 1, 2, 3, 4, 5, 6 of those. And that one's not so hard. 6 of those, and then 1, 2, 3, 4. So that's a little bit of, you guys need till Thursday? Okay, that's fine. I'll give you till Thursday on it. How about any of these? Are we okay with these? Let's just, I'm not going to go through these, but how about if we just take a quick look at strategies on this, right? So what can you tell me about this? If a pumpkin's being launched directly upwards, at 72 feet per second, and this is the model of height as a function of time, if it wants you to find the maximum height of the pumpkin and the time it takes to reach that point, what are you looking for? What if I were to graph that model, h of t? You know, so h is the, you tell me, what's the input variable for this model? T, right? What's the output variable? Height. So if I were to graph this thing then on a Cartesian plane, what quantities go where? What goes on the horizontal axis? Time, there you go, time, right? Because it's always going to be the input goes on the horizontal axis and the output, height in this case, would go on the vertical axis, right? Okay, so then this is going to give us, I mean, that's quadratic, right? Everybody agree? That's a quadratic. What is the parabola going to look like if I graph it in HT space here? Opening up or down? Okay, so it's going to look something like, we don't know the specifics, but it's going to look something like that. If I want to find the maximum height and the time it takes to reach the maximum height, where is that going to show up on my graph? At the vertex. There you go, right? The coordinates of the vertex are going to be, I'm just going to call it T max and H max, right? The time when we're at the maximum height and then the maximum height. Okay, now don't confuse this. Is this what the arc of the parabola looks like when we shoot this thing up in the air? No, it's going straight up in the air, right? All this is going to look like is the pumpkin goes way up and comes back down. That's not what we're graphing. We're graphing height as a function of time. As time passes, the pumpkin is rising up in the air, and that's going to be the time where the height is a maximum, right? So all we're really doing here is we're trying to find the coordinates of the vertex, right? We can do that. We've done a ton of that stuff, right? Okay. How about, well, I mean, you guys can probably do that. If I've got the equation h equals negative 16t squared plus 72t plus 24, how do I calculate? This is just a quadratic function in what form? Standard form, isn't it? This is like y equals ax squared plus bx plus c, only instead of y it's h, instead of x it's t. But it's still just standard form, isn't it? Right? So how do we calculate the x coordinate of the vertex? So I'm just going to call it v sub x. Now when we're using x's and y's, we call the coordinates of the vertex h and k, right? Here that h is a little confusing because h stands for height. There you go, right? And I shouldn't call that v sub x, I should call it v sub t, shouldn't I? Right, so the t coordinate of the vertex, you know, the input at the vertex is given to us by the same old formula we've always used for standard form, negative v over 2a. So what numbers am I going to plug in?
Negative 72.
Over negative 32, right? And then if I want to calculate the h component of the vertex, what's that going to be?
Plug it back in.
Yeah, right? That's just going to be h of whatever time that is, right? You guys can do this stuff, right? You can. You can. I'll take a picture of this for you guys. Okay, so we'll come back to a little bit of that stuff, but I'm going to move forward with just a little bit of review. And and this is way old review. So look at the sheet I gave you today. I'm just gonna add some little pieces of vocab, and we're gonna review some exponent rules and things. Really, this stuff you would have done in Algebra 1, and you probably did some of this stuff last year too. So first of all, we're gonna talk about polynomials. Well, what's a monomial?
One.
Yeah, what's one mean? Or mono just means one, right? So monomial means literally one term. That's all it is. It's one term. It could be a number, it could be a variable, or it could be a product of a number and a variable, like a coefficient times a variable. So some examples of monomials would be something like, would be something like 4, or it could be something like 7x, or it could be something like 3x squared. Those are all monomials, because they either consist of, or it could be just plain old x, because they either consist of just a plain number, a plain variable, or a number times some power of a variable. It's a single term, okay?
Could it be like multiple variables?
It could actually, yeah. So you're right, it could be something like this too. It could be something like 3x squared y to the 4th would also be a monomial. Yeah. Okay. Now, for our purposes, we're not really going to worry about that too much. We're going to be worrying about polynomials involving a single variable, but it's a good question, and it would work. Okay, so let's remind ourselves about some of our exponent rules, and this is going to be easy stuff for you guys. So what's the product rule? If I do something like a to the m times a to the n, what does that equal to? If I multiply like bases, I add the exponents. Good. So it would be a to the m plus n. So an example would be something like if I did x squared times x to the 7th, that would equal x to the 9th. Okay, so there's the product rule. Okay, the power rule. If I take a power to a power, what do I do? Okay, good, I multiply exponents. So that's equal to a to the power m times n. So for example, if I did x squared to the 7th, that's equal to x to the what? 14. Good. Okay, quotient rule. So if I divide like bases, a to the m over a to the n equals what? Okay, good. It's equal to a to the m minus n, or this isn't one you see very often. I'll show you why I always put this one. It's also equal to 1 over a to the n minus m. Okay? So there's a way you can think about this thing. I'll give you two examples. Let's look at, here's one example. If I have something like x to the 7th over x squared, what is that? X to the 5th. Good. Okay, I'm going to skip down for just a second to the negative exponent rule, and then we're going to pop back up. What's a to the negative m? What's a negative exponent do? Ah, okay, it pushes it, right. So a to the negative m is 1 over a to the positive m. And also, I could write this a little differently. I could also say 1 over a to the negative m equals a to the m. So there's a moral to that story. A negative exponent in the top becomes a positive exponent in the bottom, and a negative exponent in the bottom becomes a positive exponent in the top. Okay, why did I do that? Well, if we look up here, let's look at one other example. What if we look at the example x squared over x to the 7th?
5.
Oh, we're done already? Okay, we'll keep going tomorrow. Why?